and welcome everyone to our Advanced Air Mobility webinar. I'll just start, if I may, with a quick review of exactly what advanced air mobility is and how it began. It started about 12 years ago, and it was called urban air mobility at that time, and the interest was electrical, vertical, and takeoff and landing capability, battery powered, leveraging the electric vehicle advances in battery technology for air transport across highly congested areas. That business model was heavily vetted and proven, and now since then, there's actually been other business models that have come to place, particularly intracity travel. There's also regional and rural activity. There's going to be quite a bit in the area of medical services, air ambulances, and also cargo. The fundamental aircraft for this industry is going to be the electric vertical takeoff and landing aircraft. It's completely battery powered. It's a brand new kind of capability. And the flight parameters in the upper right of this slide really define a short, high fleet count, low passenger count business model. The technology needs in the lower right are no surprise, but they put tremendous stress and strain on the size, weight, and power aspects of the design engineer. So for the design engineers out there, software and hardware, what you see on this slide really is an opportunity, and once in a lifetime, really, to completely innovate and elevate an entire industry. For those of you out there who are perhaps naysayers about AAM and eVTOL, and there are those among us, we appreciate that and understand that it is still a new industry and it has challenges to overcome. But despite that, the number of orders continues to grow. It's reached about 17,000 as of May this year. In this particular chart, you see the breakdown where gray is deliveries and dark blue is firm orders. So the anticipation has been and still maintains at about 500,000 eVTOL aircraft globally across all the use cases by 2050. There's also some other backing information about the validity of the market, and these are excerpts from public postings. This is no endorsement of Microchip or by Microchip, just news of the world, really. The first use case is still targeted to be cargo, obviously the simplest since there's no people, no passengers involved, and FAA has already approved the first flight corridor for that function. Also, the investments in eVTOL developments still continue to grow. They've reached over $10 billion thus far, and that's both public and private. One thing that's very encouraging that multiple OEMs around the world are now building their production facilities at fleet grade or fleet level type quantities and throughput. This means that some of that $10 billion is shifting away from eVTOL development and into actual production. So these companies are targeting delivery of product and entry into service in the 2025-2026 timeframe. And the last thing to say about this particular slide is very important, is that the FAA has greatly accelerated its typical pace of play. They provided now very clear certification processes and paths to OEMs to get those aircraft into the national airspace in that 2025-2026 timeframe. So all the major players, the OEMs, the investors, the FAA, are all now on the same page and making tremendous speed. I do want to take a couple of those technology needs, particularly power and autonomy, and talk about those specifically through the lens of Microchip. A lot of content on this slide, but I want to focus on just a couple of things here. And that is, since these eVTOL are vertical lift and takeoff and landing, that's called powered flight, very much like a helicopter. So there's no advantage of using an airfoil like you would have in an airplane. That means that the power consumption during takeoff and landing is extremely high. Estimations are in the neighborhood of 300,000 watts in those flight regimes. To give that some scale, that's equivalent to about 70 homes being powered during those flight stages. Microchip has a product line that fits this very well. It's our line of power modules. We start on the very low power side with a baseless line, meaning that it has no heat sink at the bottom. And this gives an engineer a chance to play the weight game, the weight trade-off examination. On the opposite end, at the very high power, hundreds of kilowatts, we have particularly our low inductance module. And the low inductance allows switching to be done for the motor drive in such a way that you can reduce the EMI, the EMC, and the noise generated by the switching process. And that, again, is another engineering trade-off, EMI, EMC. This particular line, as I said, ranges across a lot of power levels, but they can be paralleled for even higher power levels. Our current maximum is a megawatt of power using multiple devices in each module and multiple modules. We can populate these modules, as you can see in the center, with a card for motor control for the gate drives. And we can also populate these modules, and we do, with our own line of silicon and silicon carbide MOSFETs and diodes. And one thing I want to make very clear about our silicon carbide is that we manufacture our own silicon carbide die at our own fab sites. Which is, unlike our competitors in that particular arena, we have complete control over not only the design, but also the fabrication process, the substrates, and how the entire process is brought to bear. That also eliminates a lot of geopolitical issues with respect to where things are fabricated. Now, for the AAM scenario, autonomy really is the nirvana position. It's completely autonomous flight, and the idea is to be able to eliminate the pilot and the associated cost and weight, bringing in other paying customers, what it really comes down to. But that autonomy inherently implies a lot of processing intelligence. So you're talking about artificial intelligence and machine learning really at the edge. There's a lot of confusion today in the engineering community, particularly in the avionics side, about what AI really means. And I want to make it very clear that it is not ChatGPT. It's not that kind of data center driven application. Instead, it's going to be based on inference engines and models, learning models, which means that there isn't necessarily a reason to have to go directly to a graphic processor. In most applications, a nice FPGA or a high-end microprocessor unit is going to be perfectly adequate to the task. So I encourage you to keep that in mind. Also, the inference engine has a big advantage with respect to actually getting your product into the market and into service. The inference engine is a much easier process for the FAA to create a certification path for, which means that it's probably going to be the first and maybe the only way to get artificial intelligence into an aircraft in a critical function. So just a heads up on that. With respect to Microchip's position on these, we have an excellent line of FPGAs. They have the lowest power consumption in the industry, and they have the highest caliber security, hardware security capabilities in the marketplace as well. And of course, the FAA is going to be raining down those requirements more and more on avionics. So the ability to get ahead of that curve and stay ahead of that curve as it comes out of the FAA and out of NIST is going to be very important, I think, to avionics developers, because frankly, most developers are skilled in what they're trying to develop, whether it's an engine controller, flight controller. That's what their skill is. The hardware security aspect, it's much easier to implement if you go with a supplier that has that expertise and has that embedded in what they deliver to you. On the microprocessor and controller side, we started with 8-bit microcontroller back in 1989. We've since brought on our 16 and 32-bit lines. What we have coming out in early 2025 is a new 64-bit line, which is going to be a significant advancement. Those are going to be multi-core devices with a tremendous amount of elevated performance. I'd like to take just a moment to talk about A&D at Microchip from a broader perspective and talk about things more strategically. Microchip Technology, in case you were unaware, is the #1 supplier of semiconductor to the aerospace and defense community by about a factor of 3. It's pretty significant. We have a tremendously broad product line that we'll talk about a bit more in a minute, and we have a very solid company, as you can see by the data at the bottom. The big thing I want to talk about also on this particular slide is those fabrication sites. You'll see some activity at TSMC. That's not unusual, but we own a great majority of our own fabrication sites, which gives our clients some protection against geopolitical issues, and that's a supply chain assurance aspect that is valuable, I think, to you as well. That broad product portfolio, as you can see across the top, touches really the vast majority of a bill of material in an avionics application. And our aerospace and defense group has the ability to pull from that entire portfolio of business units and products and flow that into the aviation defense space as chipset solutions. We can certainly provide individual components, but we also have the ability to create complete chipset solutions, again, that can set aside a significant piece of the bill of material. To look at it from a client's perspective, if you're an eVTOL OEM, this is what it would look like. You have multiple subsystems in your aircraft. You can see those across the bottom of the slide here. And our product lines feed very well into all of those different subsystems. So there's a great opportunity here for technology reuse, for reducing the cost of operations with respect to quality, managing suppliers, and reducing the bill of materials significantly as far as how many different suppliers you have to manage. One other thing that's very important for this particular market is down the left side of the slide. You'll see three different environmental categories: industrial grade, extended temperature, extended qualification. You can include automotive in that. So whatever your business model is with regard to the avionics, the electronics, I'm sorry, that you want to use in your avionics, we're going to have that environmental node that's going to satisfy your plans. And the last thing I'd like to talk about really is this idea of client-supplier alignment, this strategic idea. We are very much a company inside a company with Microchip Aerospace and Defense, because we are aligned to you with respect to being in the exact same industry. That means FAA oversight on everything we do, AS9100 certification on our day-to-day operations. That flows directly into supply chain also. As you saw earlier, we talked about the product line. What I didn't reveal to you at that time was we also are a supplier into industrial and consumer and automotive. So we actually have the ability to create product at a very high throughput. So even though AAM looks like very high quantities within an aerospace application, for Microchip, the quantities really are quite low. So there's not going to be an issue for us with respect to capacity satisfying an eVTOL client. The engineering side is also an interesting place to talk. The engineers that you have on your side are aligned with our engineers on our side. They talk the same language. They're experts in the same implementation issues. Your engineers will be experts in control systems, things of that nature. Ours will be experts in the arena of our products. So those three lines of those three bases of alignment really, we believe, motivate every reason to have conversations around part numbers. And that's the strategic aspect of what I'd like to talk about today. That kind of wraps us up. I think that we're in a position with an AAM, the eVTOL client, and AAM infrastructure to help you significantly with component, with the autonomy aspect of things, and also with strategic supply. So with that, I will say thank you very much for your time.
So to kick it off, Bill, what is the current status of the AAM market today?
Hey everyone, excuse me just a moment there. Hello, yeah, that's actually the question of the day every day. This is a fast moving market. And as I said in the video, it started about 12 years ago. And when it kicked off a lot of excitement. And where I'm headed with that is there were hundreds and hundreds of companies with thoughts and ideas about eVTOL aircraft and designs and whatnot. And that number is now down into just a few dozen, as everyone thought would happen. It's consolidated significantly. And now as we've gotten into the certification procedures and building production facilities and actually getting closer to entry to service, it's consolidating even more. So in the last, let's see, this is March, end of March. So in the last 6 months, we've seen a couple of what have been up to this point major players in the market have dropped out just before reaching certification. And so it's consolidating. But the good news is it's nothing that no one saw coming. We are getting now down to the point where the companies that are left not only have a technically viable solution, but they also have a proper leadership. They have a proper plan to go to market. And so what you should see going forward primarily are companies and plans and technologies that can actually deliver to the marketplace and exist and succeed in the marketplace. So that's what I would say is the current activity. The certification processes are really picking up quickly. Most of the technology design is done. And after that's the production facilities, and off we go.
So speaking of certifications, and you mentioned some people dropping out of the market, are there any current governmental or legislative actions that are affecting this market, either in the US or worldwide?
I'm unaware of any legislative activity that is affecting the market negatively. That doesn't mean there aren't any, just I'm unaware of any. When I think about the government activity and its impact on the market, I think really about path to certification. There are a few more, I guess, I's and T's that need to be dotted and crossed. at the FAA to really lock down the path to certification for aircraft. China is ahead of us in that regard. Their certification agency, CAAC, has finished their process. And so you're going to see the first eVTOLs enter service in China for that reason. And the EASA, I think, is a little bit ahead of FAA as well. So when I think about governmental activity with respect to the market, it really is those last few small hurdles that need to be put to bed with respect to how to certify the aircraft. And so that's my answer to that one. Is that's what I see as the government needs that need to happen, and I'm unaware of any regulations that are a negative impact that are surprises. There's always going to be aspects like noise issues, things of that nature. All of that's been accommodated and anticipated for a decade.
Yeah. And how are tariffs globally affecting this market in particular?
Good one. Yeah. The tariff activity there's nothing specific to this market that is tariff related. It's going to come down to the exact same thing it's always been for aviation in general. And what you see in this market is very fascinating. Some OEMs on this urban air mobility side, some OEMs are taking very much a integrator perspective in that they integrate the aircraft and the avionics, and they rely on other companies to develop the avionics, whether that be a traditional like a Honeywell or someone that's a little newer on the street. And in cases like that, they have the exact same tariff concerns that any other aircraft manufacturer would have. Some other companies are going to actually develop some of their own avionics. I think that there's a company in SoCal that's slipping my mind right now that does that kind of a thing. So they develop some of their own avionics. They're going to have more control over that tariff issue. But there's nothing in AAM that is tariff affected that doesn't affect every other aircraft that's manufactured, every other avionics manufacturer out there. So I see no significant impact on tariffs unique to this market.
And so you've spoken about like traditional aviation industry, traditional avionics, and then this market, advanced air mobility. What are the biggest differences for people so we aren't, I know sometimes it can be used interchangeably, but a lot of times there are distinct differences between the two. So what are those differences?
Yeah, the difference goes back to that, what I said earlier in the video, is the size, weight, power trade-off. And you can call it swap C, size, weight, power, cost. You can call it one of my favorites, swap double C, size, weight, power, cost, and certification. The last C, you're gonna have to have it in certification no matter what. And where I'm headed with it is what you'll tend to see in urban air mobility is a more emphasis on size and weight than you see in traditional aviation. Just because these aircraft are so small and they're relying on battery technology for that vertical lift. So a lot of avionics manufacturers, and I'm not going to mention any by name, but there's quite a few that are taking their traditional avionics for Airbus, Boeing, Embraer, those traditional type of aircraft. And they're going in and they're squeezing out the last few ounces and pounds of weight and reducing sizes as much as they can, but retaining the certification. So quite a bit of the avionics activity is reuse of existing technologies and capabilities. And then there's also going to be clearly some new avionics suppliers that are coming with brand new concepts. So that's one difference, is that you're seeing a reduction in the size and weight of everything that goes on these aircraft. Another difference is the business model, the fundamental business model on the human transport side there. And these aircraft, we're talking about short hops, 4 to 6 people, and the economic viability requires a quick turnaround, get right back in the air with 4 to 6 more people, and keep flying, keep flying, keep flying. So in that regard, it's a slightly different business model in go-to-market and go-to-consumer. And it's going to be an interesting growth as it ramps up in these highly congested areas. It'll start there first, highly congested areas around the world, where there's a real value to the client, to the customer, to be able to get from point A to point B quickly and reliably, rather than live through the congested traffic. So those are two things I would say are the biggest difference is this movement towards reducing the size and weight to maximum extent, but retaining the certification and the pedigree. And then this difference in the actual go-to-market and how you approach the consumer.
And you mentioned those congested cities. What are cities where you could see this market in particular, either today or very near in the future?
Most of them are in Asia, actually. That work has been, and it's not like, oh, Bill said. It's this has been well researched and well documented, from a decade back. That the first cities you're going to see that are the financial drivers, the real proofs for the financial viability of the market, are Asian cities with tens of millions of people and serious congestion problems. So it's going to be in India, China. You're going to see it somewhat in South America. You're going to see it in places like Tel Aviv. Those are the kinds of cities where the use case and the viability of the concept, the go-to-market concept, was first established. And that's, I think, where it resides still, is in those cities.
So they're going to be closer to looking like the Jetsons than we are with the flying cars and everything.
I would agree. I would agree.
And speaking of, because these crafts do need to be lighter, they're going short distances, they are for the urban environment. What are some technologies like IoT and cloud that you could see, which quote unquote don't really weigh any, like that weigh less, that could be going into these while still maintaining safety and security, because it is still an aircraft?
Yeah, that is another seminar unto itself, actually. What is going to happen, and has happened to some extent, at the FAA, is they have to realize, and they do, that for this to work and the level of autonomy that the market would like to reach, where these aircraft have no pilot, there's going to have to be quite a bit of autonomy around detect and avoid, automatic air traffic control, decision making on board, really kind of independent of any human. So part of this AI question is around the idea of how much can you have on the aircraft and actually get the processing done, have the processing power. And when you need more processing power, how to get the data for the aircraft and all the aircraft around it off to a ground station where the calculations can be done in a more in a better way, and then get that data back up to each aircraft about what to do next. So there's going to be a tremendous amount of cloud-based interaction with each aircraft. It's going to be largely around the safety aspect. But I will say that with regard to cloud, one thing that has happened, and I'll mention one example, is the Honeywell Anthem, ANTHEM, Honeywell Anthem flight deck. Honeywell has cracked the code on how to certify avionics that are both cloud-based and traditional avionics with respect to all the data and all the decision-making on the aircraft in a way that the FAA finds favorable and is certified. So it is moving in that direction already. It's going to have to continue to move even further as AAM comes to life and as a serious number of aircraft get in the air.
Awesome. And our last question, just to wrap it up, what's next? What's coming up in this industry? What are you looking forward to or not looking forward to? Or other advancements that you see coming that people should be excited about or should be interested in learning more about?
Yeah, I think that what's really exciting next is going to be as aircraft are certified here in the States, several companies have already started their production facilities. So as soon as the certifications start falling here in the States, watching those companies that have gotten to that point ramp production, and this entire industry becomes it's no longer a promise. It's no longer a slide deck. It's actually those aircraft are coming off of that production line and going into service and making profit. That's what I'm very, very excited about, because now you're going to have a completely new aspect, a new component, or a new branch in the field of aviation and in the aviation as an industry. So this happens very, very rarely across anyone's lifetime. Probably the last big one would have been jet air travel. Before that, the helicopter. I mean, this is really something that's almost like a NASA mission where, a lot of people at NASA, their whole career is one major mission, like Voyager or James Webb Space Telescope. Same kind of thing here, actually. The people that are on the call that are the younger engineers, if this is the kind of thing that interests you, there's a chance now to do something that is generational and it's only going to come around probably once in a lifetime.